My name is Peter Moffat. I work for Sheltair Scientific, and we're in a house that I've just completed doing an air tightness test on. The house uses the Superlock wall system, and we've used a fan in the front door that depressurizes the house and a smoke pencil to walk around and try to find leaks in the house. What we found is that there's almost no leakage coming through the Superlock wall, and what little leakage there is in this Quality Plus home is leaking through at the roof level and a little bit of leakage in the crawl space, but the Superlock walls are extremely tight. So it looks like the Superlock wall is a builder's answer to doing less air sealing in the house at the same time getting a nice tight insulated wall. The Superlock wall is different than the conventional wall. A conventional wall that has fiberglass in it, it can be susceptible to wind blowing through it, and when wind blows through fiberglass insulation, it loses its insulating value. But when wind tries to blow through the Superlock wall, it hits a solid surface and it can't disrupt the insulating value of the wall. As a result, you're going to get a better performance out of the Superlock wall. Originally, we thought that it was vapor diffusion that was causing problems with moisture loading in wall cavities that soaked insulation and caused dry rot to occur. But what we've recently discovered is that it's actually air from indoors, moist indoor air, that gets into our wall cavities and deposits moisture that causes the problem. So if you have a wall like the Superlock wall that prevents air from moving from indoors to outdoors, you don't have moisture condensing in the wall cavities. So you're going to get a better performing wall, and you're going to avoid the kind of problems that we have seen, especially in coastal environments where cavities get soaked and we see major deterioration of the building envelope. Fan that's blowing air out of the house. A bathroom fan blows about 50 cubic feet per minute of air, and this fan blows up to 5,000 cubic feet per minute. So it's a very, very powerful fan, and it's capable of testing very tight houses like this one, or I can go into older homes built in the 1900s, and I can test those as well. And what I find out is, in this house, the hole's probably about this big. That's the size of the hole if you added up all the cracks and the leaks, and you put it all together and represented it by one hole. That's the size of the hole you'll probably get from measuring the air leakage in this house. Where if I measured the leakage in a house that was built in the 1900s, the leakage might be as big as an open window or an open door. And that's why those houses are so uncomfortable to live in, and why they cost so much to heat. So what I'm doing is I'm measuring a series of pressures. On this gauge here, I'm measuring house pressure. And for this test, I take the house up to 50 pascals, which is a measurement of pressure. They're barometric pressure, that's the weight of the air that's in the atmosphere. The pressure that it's pushing down with is 101,000 pascals, and I'm depressurizing this house only to 50 pascals, so we're talking tiny, tiny pressure. The other pressure I'm measuring is the flow pressure, and that's the difference in pressure across this orifice plate. And what it's telling me basically is how much air I have to pump out of this house. And if the house is really tight, I only have to blow a little bit of air out to create the 50 pascals. But if the house is very leaky, I have to blow an enormous amount of air. For example, the house built in the 1900s, I'd have to open up this complete plate and probably blow my 5,000 cubic feet per minute to get the house up to 50 pascals.
Okay. Well, it's a beautiful day here in Victoria, and we're standing inside a Quality Plus home, one that's been built with Superlock wall systems, and we've just been watching the air test. It's been quite impressive to see the air tightness of the wall, a wall built with no poly, and meeting our energy efficient standards, R20 wall, looking at a wall system that goes together that's airtight, it's extremely important. During the air test, it was really interesting to walk around and feel that there was no leaks at all occurring in the wall system. It's been impressive to see the air test show that the wall system is airtight by itself, without poly, without drywall. But the wall system itself meets the airtightness test. That's quite impressive.